John Berg. I'm with Century AC Supply. I do the training here for Century AC. Today what we're going to discuss is evacuation. All of us know we have our usual vacuum pump and we have our normal gauges. What a lot of us don't know is the fact that this set of gauges really and truly is not what we use to indicate the amount of evacuation that's taking place in the system. When we first turn it on, normally it's going to go down to 30 inches nice and fast, usually within a few minutes. Many of us will go ahead and leave it on for 15 minutes thinking we're doing a little bit better job than what the minimum is. But when it comes down to it, this gauge is very, very inaccurate, and it really doesn't tell us the true vacuum of the system. The purpose of evacuation is to remove moisture, air, and non-condensables from the system. Non-condensables and air have moisture in it. And the indication of moisture in a system is not done with a standard manifold set of gauges. What we have to use is what's called a micron gauge. A micron gauge. And what this gauge does is this will tell us when, in fact, we have removed all the air and non-condensables from the system. In our installation instructions, the manufacturer states, evacuate the system to 500 microns. In our EPA, when we took our test, EPA stated you must use a micron gauge when evacuating the system. Yet, so many of us still are not using it. With R22, the oil that we used in an R22 system, mineral oil and alkylbenzene oil, were very forgiving in moisture, holding moisture. Moisture in the system is going to form, when the freon and oil, the heat of compression, is going to form a hydrofluoric acid that's going to eat the copper windings, it's going to eat the copper tubing, it's going to eat different copper parts within the system. It's eventually, long-term, going to cause the compressor to fail. The micron gauge is one sure way of removing and making sure that we have an evacuated system so that we do know we are in a vacuum. To demonstrate that, what I'm going to do is hook up my vacuum pump to my manifold hoses. Then I will take and hook up one side of my micron gauge to that hose. And what I want to demonstrate to you is the fact that when I turn this on, initially, it's going to say ATM microns, which is atmospheric microns. Atmospheric microns is 765,000 microns. We're going to reduce the micron count in the system down to 500. So let's see what happens here. We're going to hold these two together. You're not going to be able to see that, are you? We're going to hold these two together, and we're going to see, having our micron gauge beside our vacuum suction gauge, we're going to see what happens when we turn our vacuum pump on. As you can tell, immediately the vacuum went down to 30 inches. Yet here we're just now getting down to 750, 30, 10, and it's going to continue running for a little bit until we get all the air and water vapor out of the system. This is why I say this gauge here is not an indicator of truly a true vacuum, and the only way we can do that is in micron reading. Earlier we tested this and we got down to 500 microns. And always what we want to do, and here we are down to 590, but this isn't happening within a few minutes or seconds like this happened. The purpose of this micron gauge is to truly give us a sense of just how dry that system really is. To further prove that, what I'm going to do is I'm going to hook my other hose up to a bottle that has water in it, ordinary water. Your air conditioning system will not have this amount of water in here. But what I want to show you is, with this hooked up, again, with our gauge reading 0, with our manifold hose hooked up, one of our hoses hooked up to the bottle of water, and with our micron gauge here, we're going to open the system up again, and I want you to see how quickly this is going to go down to 30 inches, but I want you to pay attention to what this micron gauge is doing. See how quickly that gauge has gone down to 30, and look at the activity that's happening inside my bottle with the water boiling. This is moisture in the system, yet my gauge tells me I'm at 30 inches of mercury, indicating I've done a good vacuum job. How can I have a good vacuum job when I have this much water still in the system? Remember, this is going to form hydrofluoric acid. It's going to damage the internal parts of the air conditioning system. Again, we're just down to 7,500 microns. Still boiling, still reading 30, still not anywhere near the 500 microns that we need to be. By seeing this demonstration, I hope what I have shown you is the fact that our gauge, even though it's reading 30, is really not an indication of just how much air, non-condensables, and water we have removed from the system. To do the job correctly, to evacuate the system correctly, we have got to start turning to and using and depending on our micron gauge to be the true indicator of just exactly how dry our system is. The new refrigerant and the new oil do not allow us to leave air and non-condensables in the system. The moisture in the system is going to cause damage internally a lot faster on account of the according to the on account of the ability of the oil to retain the moisture even in an evacuation. Even if we're down to 500 microns, if there is moisture in that polyol ester oil that's used for 410A systems, we're going to see, until it goes through a filter dryer, that moisture is not going to be removed. We can pretty much depend on a premature failure of that air conditioning system at some point. It may be 1, 2, 3, 5 years down the road. We don't know, depending on the amount of moisture. But remember, this is how much moisture I was able to have in my system, and I still read a 30-inch vacuum.